All right. So, just to do a quick recap, we currently have a German Shepherd dog. We have enforced inheritance. We saw a little bit of polymorphism there, which is our init on our super init. But let's start talking about this. A couple of other examples of polymorphism. So currently here we have our dogs in our dog pound. And let's say I want to do a little bit of a change over my fetch and speak methods. So, for example, my fetch method, I don't really want to change that too much within my German Shepherd dog, but I could change my bark method within my German Shepherd dog. So I could say speak, which takes in self, and return something like, let's do self.name is barking very loudly. All right. Well, let's take a look at what that looks like. Currently, I can call Apollo.speak. I can pass in this method and print it out. And I can do the same thing for good old Scrunchy right up above. All right, so here we can see that the speak method is working for Scrunchy as well. Scrunchy doesn't have a speak method. It's bringing it in from the dog class. If I don't call their methods and I just print the actual method location, you can see that the pug is calling the dog speak method, whereas the German Shepherd is calling the German Shepherd speak method. All right, so there's a quick hint of polymorphism. The same exact method is being utilized to accomplish one goal, but the logic is being changed behind it. Now let's talk about the fetch portion. What if my pug can't fetch? So when I call the fetch, here we can see that it's passing in fetch item. And I think this was a question that you had earlier, Arnold. You can see how it's calling the super method and then trying to fetch something. But I don't want to do it this way. Instead, I want to say return, again, F string, self.name is too small and doesn't like to fetch. All right, so now I can call the fetch method in both. I can pass in an item to both. Let's say stick. And then I can execute. So we can see a follow is fetching the stick, and Scrunchy's too small and doesn't like to fetch. All right. Again, all I'm doing is taking in the original method and overriding it. I am redefining that method. It's almost like what we're doing within the class attributes here for breed and lifespan. We're just setting a new definition to a method. We could do the same thing with getters and setters if we needed to. And that's the concept of polymorphism. Does anyone have any questions over polymorphism? Let's hear it, Thomas.
Sure. On your pug class, item is grayed out, so would you still need to pass in item?
So I still need to pass in item because the function's expecting it. If I don't pass in the item, even though I'm not utilizing it, it would raise an error telling me that I'm missing an argument. Yeah, so missing one required position argument, which is item. So I would still need to pass in something even though I'm not utilizing it.
Okay, sorry. I think I might have missed the first part of that. I thought you might have done something with the parent class dog. So Never mind.
Got it. All right. Any other questions?
Just for clarification's sake, does the parent class dog have any fetch method right now?
No. So
Okay.
wait, which one? Dog or German Shepherd dog?
Dog.
Dog does have a fetch method. Right here.
Got it. Okay.
And
Okay.
that's the one that Apollo is utilizing. So Apollo is using this fetch method.
Oh, I see.
Scrunchy is utilizing this fetch method.
Because you reassigned what fetch does.
Right.
Got it.
All right, Arnold.
So under the pug fetch, so does that mean we don't need to put in the parameter item then? It's already in the dogs fetch.
No, because again, I'm redefining, right? So all the polymorphism does is essentially, let's talk about it from a Python level, right? Not from the way that we're seeing it in code, but talk about it from a Python level. What it does is it says, hey, does has attribute. So does dog have an attribute named fetch, which would be a method, right? So if it does, then fetch is equal to, and then everything from 27 down below is what's set to fetch. All right. And this only happens because I'm assigning a new variable. If I were to name this fetching pug and I execute my code, you can see that Scrunchy starts to fetch the ball. That's because I'm no longer redefining the information for fetch. I have two separate methods, one named fetch pug and one named fetch. When I take off this underscore pug, well, now I get the refusal to fetch. And that's because we are redefining the fetch method here for the pug. Did that clarify things, Arlen?
Yes, thank you.
Of course. AJ?
Yeah, I know I'm slow in the take up at times, but I'm trying to I'm still not understanding how everything's interacting with each other. I know you've explained it a few times now. But is it possible to see that visual chart one more time?
Yeah, absolutely. Are we talking about this one or? Okay. Yeah. Let me see if I could put this side by side with something else.
Yeah, I think it helps me process stuff when I see what's going through what specifically. Because the code, the strings and all that stuff, it's hard for me to track sometimes.
Yeah, absolutely. So here we have our data, which we know what we're talking about here would be a name, which has, I don't know, let's go with the polo, why not? I'm actually just going to copy and paste this information rather than writing it from scratch. All right, so here's the data that's being passed in. It then gets passed into the init method, which the init method would be German Shepherd dot init, and that's where we're doing this star data. Or if we want to do it this way, right? And what that does is it falls into the init method. Do it this way. Where we have name, height, weight, color, temperament, and trained. So that's all happening there. Then it goes into the init method, or excuse me, the super.init method. Which super is in reference to, hey, I want to leverage the parent class here that holds name, height, weight, color, temperament, but doesn't actually hold trained. Okay. Then down below, inside of the dog init method, that's where we get all of this self.name is equal to name. We get self.height is equal to height. Self.weight is equal to weight. Self.temperament is equal to temperament. And self.color is equal to color. Nope, that didn't work. I think it will. And I apologize, but here is also where we see self.trained is equal to trained. All right, so that's how we end up with a German Shepherd dog at the very end. So this entire process outputs an instance of a German Shepherd dog, German Shepherd, that holds class level attributes, which we have dogs. This one comes in from the dog class. We have breed, which is set to German Shepherd, which comes in from the German Shepherd class. And I'm just going to do GS here for shorthand. We have lifespan, which is set to 13, which is also coming in from the German Shepherd class. And then we have some instance attributes. Do this way. Where the instance attributes are of name, height, weight, temperament, color. Am I missing something? Name, height, weight, temperament, color, and trained. Where only trained is coming in from the GS class and everything else is coming in from the dog class. Did that help clarify things there?
Yeah, I think it helped a lot.
Of course. I'm sorry, I can't fit this all inside of the frame, but it's there. All right, Alex.
This helped a lot. But my question is, I'm a little iffy on the star data. Is that a Quarg just with a different name? But or what does that do again?
It is almost like quarks. It's a keyword argument. All right. So what it's doing is it's destructuring this dictionary
Uh-huh.
so that essentially it finds, it says, hey, we need a positional argument of name. And let me actually utilize a different color here. I'm going to use my zoom tool. We need a positional argument of name. Well, let's take a look inside of this dictionary, and it's doing that from this star star, and it finds the keyword name, so it assigns the value back to name. Does the same thing with height. We need height. Is that inside the dictionary? Here it is. Well, let's give the value of height back to that positional argument, and so on. It's kind of like a fetching that happens there. It looks for the keyword within the keys of the dictionary.
So is this just dictionary based?
The star star, yes, it's a spread operator for a dictionary.
Got it. Okay. And say for instance, you don't have, you're still gonna raise an error even though you're using the star star. You'll still raise an error if there aren't enough arguments or if there are too many arguments passed into that dictionary.
It would, yes, because it's
Got it.
expecting that by the end of this, there would be no leftover values to try to match with the init method.
Okay.
And it's also expecting, so for example, this is already looking to be fulfilled, right? So if it's missing anything, it's going to raise an error. And this star star operator is basically shoving this entire dictionary into the init method. So if it's too much, it would also raise an error.
Okay. And then another question is for the super init method. When you're setting that up within your child class, right? Okay. Yes. And it's underneath the German Shepherd init method. This happens underneath within it.
Yes, it's nested
Okay.
with.
So when you're setting that up, if you don't, when you're setting up the super init within your child classes init, if you don't feed in, say, for example, height, will it ignore height, or is that, will it raise a error for positional arguments?
It would raise an error for position arguments because the init method within the dog class needs to be fulfilled. So if we don't pass in height, it would say, hey, I'm missing an argument for height, or whichever the very last one, the last argument that it's expecting.
Got
Right?
it.
So that's the reason why we're essentially copying and pasting this entire first portion to match right here.
Okay, that makes sense. Yeah, I was a little confused, but then, so all we're avoiding, not avoiding, but we're not repeating ourselves with the super init is the self.name equals name. That's what is helping us not repeat that part.
Exactly.
Okay. Cool. Thank you.
Of course. All right, Sam.
I'm going back to Tom and Arnold's question with the when you redefine a method. So when you redefine the method in the child class, do you have to have the same number of arguments as the original method, and do the argument keywords have to be the same?
Got it. So argument keywords do not have to be the same, and you do not have to take in the same amount of arguments as the child class. Since you're redefining, you could just simply say, hey, this is not going to take in any items, right? And now when I try to execute it, I should get an error because I am passing in an item. So there it is. It's telling me, hey, we only accept one, but two were given. So let me take off this ball portion. And now when I execute, it works perfectly fine for Scrunchy. So notice how Apollo still needs an argument. Since Scrunchy's never going to fetch, I could change that, right? This is me speaking for my design and my opinion specifically to answer your question. Well, first of all, does this answer your question?
Yeah, that answered my question.
Okay, perfect. So this is me from my specific perspective when it comes to designing code. You want to keep things as common as possible. So let's say that we can still take in the parameter, all right, of item. That way, anytime somebody utilizes this function, they know that there is a consistency. I need to pass in an argument, regardless whether it's utilized or not, right? Or maybe I just give this a default value of saying, hey, none, if they don't pass in. But it still accepts it, whether it's passed in or not. And I can also pass it in without any information. Right? That way there's just a concept of consistency. Does that answer your question, Sam?
Yes,
Or
thank you.
that wasn't even your question. That was just my rabbit hole. I apologize. All right, Cricket.
So when you add something on the super method, it's gonna update everything to the top.
Sorry, I may be unable to understand your question. Could you say that one more time?
So you can add it when you're using a super method, right? You can add it like in another like parameter or argument.
Yeah, so if I have my super method here, I believe this is what you're referencing to. I added a new argument named trained, right? But notice how I didn't add that trained argument to the super method. Trained is within the init method that belongs to the German Shepherd. And it doesn't get passed into the super method. It gets assigned as an instance attribute, right? I can't just, if I'm passing in a new unique value. So for example, trained is not something that I wanted to fall under Chihuahua. It's not something that I want the pug to also have. It's only something that I want the German Shepherd to hold. Well, I would place it here and pass it down below. Now, if a new variable came up that I said, you know what, all dogs need to have this one variable because I'm rewriting this over and over again, then I would go over to the dog class and add it here. Right? That way it can be something that all dogs or all instances of a type of dog would also have as a instance attribute. Did that? Okay, got it. Any other questions? Let's hear it, Sam.
Yeah, so when you make a new argument that's required, so like trained, should you always do like the self.trained equals trained after the super?
Let me see. Could you say your question one more time?
Yeah, when you're like, for the child class initialization, if you're adding a new argument, so like in the German Shepherd example, you're saying trained, should the self.trained equals trained or self dot whatever equals whatever always come after the super?
No, you could definitely change this in between. It's common practice to have the super first, just so that the initialization is obvious to everybody. Everyone is tracking, oh, okay, the parent class is already initiated and it's being utilized, so I don't have to worry about it. Common practice is you define your init. If there is a super init that you're going to utilize, that would be the first line of code, and then all of the next attributes come after. All right. Any other questions? Perfect. It doesn't seem like we have any other questions. So let's close the loop here by talking about the difference of inheritance and composition. So inheritance, and this is the easiest way to remember it. Let me put this handy dandy tool to sleep again. All right, so inheritance is a relationship or has a relationship where it is for example, a German Shepherd is a dog, right? A pug is a dog. Now, the concept of composition is of has a. So, for example, a German Shepherd has an owner. a pug has a favorite toy. And so on. So we could define these classes really quick, but that's the main difference there. Whenever you're thinking, should this be inheritance or should it be composition? Well, just ask yourself, is it an instance or is there a relationship? Are we looking at an is a relationship or are we looking at a has a relationship? If it has a relationship, then we're looking at composition. And if it is a relationship, then we're looking at inheritance. All right. So let's do that really quick. We're gonna go ahead and quickly make a owner class. And currently my owner is not gonna have any sort of crazy stuff. I'm just gonna do init and let's do self comma age. Okay, fantastic. Now, actually I'm gonna take this out here. Take this over to dog class. Okay, so there's my owner. I have age and let's add in name. My fingers are not collaborating. There you go. Or cooperating. One of the two. They're not working. There you go. And let's go with self.name is equal to name. And finally, self.age is equal to age. Here I can have a dunder method. I can make getters and setters if I wanted to. I'm not trying to overcomplicate this lesson any more than what it already is. So I'm just going to leave it as such. And then I'm going to make dog owner. Or we could simply just say Francisco is equal to owner. That will take in the name of Francisco. And we'll take in the age of, let's do 27. Right, so now an owner has been created. Now, what we're looking at is a has a relationship. All dogs will have an owner. I can say owner is equal to none. Now, in dog types, I can bring in owner, make a declaration there. So now there's the owner. And I can say a couple of dogs have an owner. For example, this German Shepherd, I want the owner to be Francisco. And now if I go to my runner or my main file here, let me open that up again. You can see I'm not changing anything to Apollo. I could change it so that within the initializer, it gets assigned an owner. Here I'm going to go ahead and print Apollo.owner. You can see that in dogs, there's an owner object. That's what I expected. This is happening because I don't have a dunder string method. But I can always just do dot name. And now we will see Francisco. So this is composition because a German Shepherd has a owner. In this case, the class that I'm having a compositional relationship with is owner, where I'm assigning it to an instance of owner. I'm not assigning it to the entire class. I'm assigning it to an instance of owner. You could do the same thing with something like toy. Say class, toy. Let's do an init method there. Let's do self, comma, name, comma, and then let's just do price. You can do self.name is equal to name, and self.price is equal to price. If I go to my dog types, I can bring in the toy. Here I'm going to make an instance of it. So I'm going to say ball. is equal to toy. The name of this will be of ball. And let's say that it runs around $5.25 for the price. Well, now this dog may have a favorite toy. I can come over to my pug, right? Or I can even come over to my German Shepherd. And let's say all instances of a German Shepherd, they just love to play with this specific type of ball. Well, I'm going to say self dot favorite toy is equal to ball. So now I can say Apollo dot favorite toy dot name. And what I should see being printed out is ball. If I just print out favorite toy, I'll get a memory location. And I can even take a look at the price of the favorite toy. Again, it's a compositional relationship because Apollo, not just a German Shepherd, Apollo has a favorite toy of ball. All right. Any questions regarding composition? Go ahead, Alex.
When you when you add favorite toy within the init method of German Shepherd, how is it accessing ball? Are you assigning the instance you made of a toy to it? So German Shepherd ball doesn't have not really doesn't have is not directly linked to the toy class.
It is, and not, oh, I see what you're referencing. So what we're saying is we're not actually calling, no. So it's not directly linked to the toy class. It's linked to an instance of the toy class. That's why
Got
it's
it.
has a relationship.
Okay. So in composition, you're not really directly linking, like toy isn't going to go anywhere in an argument of German Shepherd dog.
I don't want to say that because you could create a method saying, let's say you create a method saying that states add favorite toy or link favorite toy. And then in that case, you could call the toy class within the German Shepherd, right? But again,
Okay.
the link would be to an instance, not the class itself.
Link would be okay. Got it. Thank you.
Of course. All right, Tom.
So what would be the difference of making it a class attribute versus an like say an instance attribute? Because that's saying like, all German shepherds have this owner or whatnot. And since it's tied to a instance of an owner, couldn't hmm, I guess I'm just confused on the use case of it, I guess, because like it seems like it would have to be very broad and um seems like it would just be another class attribute of sorts.
Yeah, let me go ahead and make this a little bit more clear here. I'm gonna actually take all of this out. And instead, I'm gonna pass in owner and favorite toy. Which for favorite toy, I'll set it to none. All right. So in this case, what I would do is when the create dog method comes through, I could even set owner to none if that's what I wanted to do. And I apologize here. This one should be German Shepherd owner be equal to. Right, so let's say all German Shepherds will be owned by one specific person, and German Shepherds may have their own toys. Well, let's quickly create 2 of them here. Let's change Apollo for Zeus. I'll leave all the other information the same, except that I'll actually pass in owner. And let me make sure that I imported that. I did not. So let me grab owner and grab toy. So here I'll pass in an owner, where the owner instance will be of name. But did I not bring an owner? I did bring an owner. Okay, it's not tracking what I'm trying to do. So let me go ahead and go here so I can see what's happening. Easy peasy. Pass in Francisco. And that's probably why it's not tracking what I'm trying to do, because of syntax errors. Pass in 27. Here I can pass in favorite toy. And what this favorite toy would look like would be an instance of toy, where the name would be ball and the price is $5.27. So now if I print Apollo dot owner, and I print Zeus dot owner, that will be the same for both of them, because that's being set as a class level attribute. Right, so here's the class level attribute that's being set to the owner. When I execute it, we can see both of them have owner objects. And if I go to both of them and I change this to name, we can see that both of them would be Francisco. Right? So that is a class level. Now, instance, we have toy. Well, let's change this to favorite toy. Well, now, in the first one, we see none. And in the second, we see an actual instance of the toy. So I can see the name of the toy. And now we see none and ball. Right, this would be more of a practical application where it would be utilized. It would actually get passed into the initializer, and then the initializer would manage all the data information. Did that answer your question, Tom?
Yes, it did. Thanks.
Awesome. Tony?
So is it fair to say that composition is in itself kind of an inheritance, but from an instance? Like it's inheriting the dictionary of data from the instance?
I'm gonna go with no. I don't want that spelling to, or that phrasing to affect how information is being passed. So if I go back to this example here, right? Dog has all this information. Well, now I also have an owner. And I also have a toy. Now, an owner, because it is a class level attribute, it falls between here. And this owner, it's not within it, it has an attachment to it, to an instance of the owner. All right. Same thing with the pug, or excuse me, whichever dog we want to talk about here, because I don't have the German Shepherd. It isn't a toy, instead it has a relationship where it has a toy. Right? There's no inheritance. It's just has a relationship. Did that address your question, Tony? I think you're understanding it or at least I know you're understanding it fundamentally, and I understand your phrasing. I just want to be careful with saying that it's a good idea.
Yeah, I was speaking more along how the data was passed along. So it's inheriting the data, but not necessarily the toy, more or less. It's taking the data from the instance. That's what I was. Yeah.
Yeah. All right. Any other questions? Okay, perfect. I did want to go over the task application, but at this point we are kind of running out of time. There is something called abstract classes that I would like all of us to kind of break down a little bit. So in the concept of dog, for example, we talked about speak. Well, we also know that all dogs need to eat, but they might eat differently or even sleep. Those are common things that need to happen across all instances of dog. But we don't know how exactly that needs to be executed. We know that the method needs to be created and that it needs to be enforced in all the children, but we don't know how it's actually going to be executed. So that gives us a little bit of a problem, right? Because I can say, all right, well, there's a method here that all instances should have, and this method should be of, let's call it sleep. And it should take in self. Now I'll just pass and say pass. They still have Scrunchy available up here. Where are you at, Scrunchy? Here you are. And let me clean this up a little bit. Okay, let me make sure that Scrunchy works. And same thing for good old Polo. Okay, so both of them are working. We have Scrunchy and Apollo available to us. But now let's say that I want them both to sleep. Oh. Well, the method is there for both of them, but there's no actual implementation of them within the Pug or the German Shepherd class. Now, when developers inherit a class, I want to tell them, hey, there is some sort of reinforcement. Like, I need you to overwrite this method. You can't finish off your class without overriding this method. Well, in order to turn this into a requirement without anything in the body, I would have to import an outside library called abstract method. So I'm going to say from ABC. This is built into Python, so we don't need to pip install anything. I want to import ABC and the abstract method class. So here it is, abstract class method that's been imported. It's not accessed. Interesting. Okay, so this portion of the class, I'm going to go ahead and pause it here. From what I can see here, it seems that it's been deprecated. So I don't want to teach it. It's not going to be in your assessment. I'll go ahead and review this material to make sure that it's still up to date. But there has been some rework of Python, so there is a good chance that this, in fact, has been deprecated. I apologize, everyone. All right. In that case, let me do a quick review over what we've talked about here. So today we covered inheritance, polymorphism, and composition. We talked about what is inheritance. We didn't talk about the why, but we definitely saw it, right? We wanted to make sure that we don't repeat ourselves, and inheritance accomplishes just that. We're able to grab a specific blueprint and expand upon it through inheritance. And an earlier example that we saw for inheritance was the iPhone. where a new version of the iPhone was inheriting from the version prior to it with just one new feature inside of it, or a couple of new features inside of it. Here we have an inheritance example. We saw the conceptual example, which is the dog. We didn't get to the programmatic example, which was our tasks. But with the dog class, we have everything that we need to be able to implement everything, all these concepts. We talked about composition, and then we came back and covered polymorphism, what it is and why is it important. All right, at this point, does anyone have any questions over inheritance, polymorphism, or composition? Perfect. If there aren't any questions, I'm going to go ahead and stop our recording here.